Hi guys, so this notes here on the intuitive idea of probability and its notation. We're basically just going to talk about using verbal descriptions to describe how likely an event is to happen, okay? So looking at the top right-hand corner of your notes, it gives you kind of like a fraction. In the denominator, it says the number of total outcomes in the sample space and then the number of successful outcomes. So we'll actually be referring to this on the back side of our notes, but just be aware that we have this here to refer back to. Okay, so when the time comes, we can actually flip back and look at that. Okay, what we're going to be looking at is the range of values. So how likely something is to happen. Our range of values, we're going to go from 0 just to the whole number of 1 there. So what I mean by that is, let's say, okay, the probability that it's going to snow on a summer day, right? So let's say the probability, I'll call that event A. So again, how likely it is that it'll snow on a hot summer day. On the probability of that, we would consider that 0, right? Let's say the probability of event B, which is, let's say, how likely it is to rain on a spring day. So rain's pretty common in the spring, right? So we could say, we call it maybe 0.76. You can almost think of that like 76%, but our range of values is going to be in between 0 and 1. So I'd say, okay, that'd be 0.76. That's approaching 1. That's pretty likely to happen. Okay. We can also use percents. So if I were to say the probability of event C, let's say event C, is it to, let's see, thunderstorm on a spring day. So again, maybe that's a lower percent. So I can just say that's 30%. Okay. And then last but not least, let's say the probability of whatever event D is, you can never have that equal a number greater than 1. So a lot of you guys, if I were to say, what's the probability that it's going to be over 30 degrees on a summer day? That's pretty much guaranteed, right? Summer, we know it's going to be hot weather. You would never say 100 though, okay? Again, you want to keep those ranges in between 0 and 1. So just a reminder that you would never actually write, so the equal sign with a slash just means it wouldn't be equal to 100. You'd be writing your values in between 0 and 1, or you'd be writing them as a percent, okay? So our verbal description of some possible likelihood examples, if you guys see the little chart over here, so 0 means it's absolutely impossible. Your 0.25, that means it could happen, but it's pretty unlikely, okay? 0.5 means it's equally likely, so like flipping a heads or tails on a coin. Okay, 0.75 is going to be likely, so again, that might be having rain on a spring day, that's pretty likely. And then 1 is completely certain. So again, in summertime, the chances that it's going to be over 30 degrees, that's almost guaranteed, that's almost certain, okay? So just to kind of give you guys a little bit of verbal descriptions and like how we can compare those to numbers. So again, the probability of event A equaling 0, that means it's impossible. Okay. Anything that's greater than 0, okay, so let's say the probability of event A being greater than 0, but less than 0.5. So notice it's not less than or equal to, it's just less than. That's going to be considered unlikely. So it means like 0.49, 0.48, 0.01, 0.02. So all those decimals in between 0 and 0.5, okay? When the probability of an event is exactly 0.5, that means it's equally likely. So again, like flipping our heads or our tails there, okay? Any event that's greater than 0.5, right, but less than 1, so again, it can be 0.99, 0.98, 0.55, 0.60, just those numbers in between 0.5 and 1, that'll be likely, okay? And then the probability equaling 1, that means it's absolutely certain. Okay, and they give you guys this visual over here just to kind of compare what I just wrote off to the side here. Okay, so our instructions for some practice down below say determine if the events are I for impossible, capital UN for unlikely, capital EQ for equally likely, capital L for likely, or capital C for certain to happen. So example A says getting a red on the 4-color spinner. So red is just this little sliver right here. Okay, so it's less than half but greater than 0. So less than half and greater than 0, right? That's like our one right here. That's going to be unlikely, right? You can kind of just use a little bit of common sense to be circling those. You don't have to actually refer to these. If you're still confused, you can always refer to these here. But you can kind of use a little bit of common sense, okay? Rolling this dice and getting a value greater than 1. Let's see. This is greater than 1, greater than 1, greater than 1, greater than 1. You have 1 that is exactly 1, okay? That's very likely to happen, right? It's not certain because that's 1 and that's not greater than itself, but you have 1, 2, 3, 4, 5 out of 6 options to be getting that number greater than 1. So that'd be considered likely, okay? Selecting a football from these balls, since you have no footballs here, right, that's going to be impossible. Okay? You don't have the option of picking a football there, okay? Getting a red chip. So these are kind of hard to see, but we got red here, red here, red here, and then 1 green. So again, that would be pretty likely, not certain, only because all the chips are not red, okay? Getting a green chip, looks like we have 1 green chip, and then the other 3 are red, so that would be unlikely, not impossible. It's just a lower chance of getting a green. And then getting a round chip, since all these chips are rounds, that'd be pretty certain, right? You'd be choosing a round chip every single time. All right, so now the back side, it's actually going to ask us to determine the basic probability. So this is where I'm going to be referring to the little fraction here. Again, you'll see how I'm going to be using those as my responses. So it says, in a bag of 3 red, 2 green, and 7 yellow marbles, picking a yellow. So what is the probability of picking a yellow? Well, I have 7 yellows in that bag. So it's going to be 7 out of the total amount that I have in that sample space. So 7 plus 2 is 9, plus 3 is 12. Okay, so that means 7 out of 12 would be my probability of selecting yellow. So that's just the number of successful outcomes. So the number of yellow I had was 7 out of the total outcomes in the sample space, which adding up all the marbles was 12, okay? My next one's selecting a pink. Now, since there's no pink, right, that's just going to be 0 out of 12. And then selecting a green, that is 2 out of 12. Now, some of you are thinking, oh, 2 out of 12, I can simplify it to 1/6. I do not want you guys simplifying your answers here. Okay, just keep them as they are. What you can also do is that once we actually have these written in fraction form, let's just pair the verbal description to it. So 7 out of 12 is more than half, right? So that's pretty likely. That's not equally likely or certain. It's kind of in between. Okay, 0 out of 12 we know is impossible. Okay, and then 2 out of 12 would be unlikely, right? That's less than half, but greater than 0. Okay. All right, now working back to the standard deck of cards. So remember in our old notes and sample space, you guys have that little visual of what all the cards in a deck look like. So it's saying the probability of selecting a red card. So something, if you don't know this about a deck of cards, that half the cards are red and half the cards are black. So that means a red card, the chances of picking that would be half of 52, which is 26, out of the total deck of 52 cards. And since that's exactly half, that would be considered equally likely. Okay. The probability of a 4 of spades. So 4 of spades is a very unique card, right? There's actually only one 4 of spades. You have the number 4 card 4 times, but each time it comes up, it has a different suit. So there's a 4 of spades, 4 of hearts, 4 of diamonds, and 4 of clubs. So there's only going to be one 4 of spades out of a total of 52 cards there, and that's going to be pretty unlikely, right? The chances of getting that are very slim, okay? And then the probability of selecting the 2. So again, for each number that you have in your deck of cards, so 2 through 10, and then your ace, your jack, your queen, your king, you have 4 of each. Okay, so I'd have 4 number 2 playing cards in there. That's going to be 4 out of 52. And again, I'm not going to simplify. I'm just going to keep it as that, and that would be unlikely, right? It's less than half, but greater than 0. All right, in your last section here, rolling the special die once. So the probability of getting a 1, so 1 only pops up 1 time out of 1, 2, 3, 4, 5, 6. And that's going to be considered unlikely. Okay, the probability of getting a 3, so 3 comes up 1, 2 times out of total of 6 sides. So again, that's pretty unlikely as well. And then a value greater than 2. So greater than 2, it can't be 2 or 1, but 1, 2, 3. We have 3 sides there that are greater than 2 out of 6, and that would be considered equally likely.